I will show you how data classes can make your code cleaner. What you see is some example code of a product list. Each product is a dictionary. I bet you can find such use of dictionaries in many widely used applications, but it's probably not the cleanest code and could be improved with some data classes, which are just another tool that can make your code not only cleaner, but also more object-oriented. In case of this example, we have some data that follows strict structure. We always have some name and price. We also use that data many times. Those products could be created from data that comes from database, or maybe they are from user input and later that will be transferred to the database. We may want to create some reports, update prices, and more, and that means we are accessing values of those products many times. We are going to read values and maybe also modify them. In that case, I believe dictionaries are not the best fit. I would love to use a dictionary if that was just a configuration file, just some JSON that I load from my drive and don't have to modify values many times. Also, if I was using such JSON, I would probably use some way of enforcing schema, like using JSON schema module. If I want to modify, for instance, a t-shirt name, I have to access it each time, and when I start writing the code, there is no autocompletion because PyCharm knows that I'm trying to work with a dictionary, but it doesn't really know what data to expect and what are the keys. I could try having some type hint for dictionaries, but they seem to be a bit more complex than when it comes to other data types. And if I make any typo, I'm going to create a new value keeper in my object, but the old value, which is a t-shirt here, will be not modified. So I will have not only a bug, but also I will not notice it because that won't raise any exception. Exception will be raised when I try accessing the data by wrong name, and if I run my application, you can see that we have a key error. However, this key error can be avoided by using a get method, and not only it will avoid an exception that probably could have raised my attention, but also now we are going incorrect value. And what if customer orders something and value of none would be interpreted as 0? In that case, we are causing additional expenses for the company. So don't get me wrong. I like dictionaries. They are great. I have number of uses. But if you need a data structure with fixed names, types, and values, and also some autocompletion, you're going to have many reads and writes in your code, it's worth trying classes. So we will rewrite this code to a class and then we will modify it so it's an actual data class to make it even better. We have to create some simple class that can store our name and price. So let's create a class called product and an initializer. The initializer should expect name, which is a string, and also price, which is a float. We should assign them to proper attributes. And that's done. Now we have to make that class used instead of the dictionaries we had. So just give me a second to correct the already existing code. That went smooth, and now we probably also have to correct the code on the bottom of the file. We are no longer accessing those properties like in dictionaries. Now we can just access a single object from my list by using a dot and use a name or a price. And when I do it and I put another dot, my suggestions are fitting the type of the attribute. I have set a string, and my IDE, which in this case is PyCharm, knows that this is a string. So I can use some join method, upper method, format method. And if I was playing with price, I would have only some methods for floats. So that is great. We can get rid of the old code and execute it. It kinda works, but something is wrong. When we were working with dictionaries, printing the values was working out of the box. Now, I wouldn't say it's broken, because it apparently doesn't crash the application, but that's not the result we expected. We have some name, probably of our module, then another name, which is of our class, and information related to the place in memory that it takes. That's probably the index, but that's not very helpful for the user. If we really need a human readable data, we have to create a string dunder method that returns a human readable representation. So if I create a string method and I return example, now we will print examples. So let me create an f string that will print name and the price. So f string, now name, and also the price, and maybe a dollar sign because we're paying in dollars. Let's execute that. That works nice. But if we wanted to add more attributes on different iterations of the development, each time we would have to update both the initializer and the string. And honestly, our class didn't have any other functionalities. It was only a data container. Let's use data classes instead, because they are exactly made for this kind of data containers, and they will generate initializer and the string dunder method for us. So let me import data class decorator. From data classes, import data class. Now the data class decorator goes over definition of my class. And we no longer need the initializer. We only need to define attributes. So now that is done, and I don't have to modify already existing code. We can just run it. There is slight difference though. Oh, and let me remove those braces because they weren't needed. There is slight difference though. Now we always print name of our data class and then parameters in brackets. If you don't like the way it works, you have to implement a dunder string method yourself again. But if that's acceptable, let's skip it. That's all about the basics, but we can do more. For instance, you may want to set default values. If we are making a dollar store management software, you may want the default price to be exactly $1. And in that case, we just have to find the attribute we want to add default value to, and at the end of the line, add equals to assign some value, and let me assign 1.0. And we no longer have to add price for the notebook, nor for the cheese. We can execute the code, and prices are fine, just like in the past. That can be a bit more complex when it comes to complex variable types like dictionaries and lists. Let's suppose we want to have some ingredients list, some composition of the product. So let me add a new attribute called composition. And I would like it to be a list consisting of strings. And when I use type hinting with complex data types, I never use lowercase names of our data types. I always go with the uppercase and I import them from typing module. That is just an alias that can help us avoid any runtime issues, especially if we are trying to nest types with each other or make some unions like this type or another, or some optional types. Here I add the brackets and I want that list to contain strings. That's great. And now I shouldn't assign a value like here. PyCharm is actually quite smart and it tells me that mutable default, just brackets, is not allowed and I should use some default factory. But if I was able to execute it, or maybe I was able to execute just a list function, but here I also see that it's not possible. But if I was able to do that, because I can run this code, and right now Python is smart enough to detect that, but in the past we probably would be able to execute it. If we did it, that value would be evaluated at the very beginning of our script, and all those objects we have here would probably keep the reference to same object of a list under the hood. So if I started adding some elements, they all would be always the same, which would be an issue. To fix that, Python creators added a field keyword. Actually, not a keyword, it's a factory that creates objects for us, and we have to import it from Dataclasses module. And there we can give it a default factory value, which should be some function or method that returns the desired value. That sounds a little bit ambiguous, but it's actually simple. Let's suppose you wanted to create an empty array. Instead of creating it by using the square brackets, you could also call a list function. But the function could be also passed as an argument. The fact of using braces here means that we are calling it, but without the braces, it could be just used as a value. So why don't we place it as an argument of our default factory, and now when we execute the code, we always have an empty list here. But what if you want it to have actually some value? You could create a function yourself. So def return me a list, and we're going to return a list that has tomato and a potato. And we can use it instead of that list function, run it, and that works. But that is a very short function that is not going to be used anywhere else. So I could also create it kind of like an object using a lambda keyword. So I will use lambda, and here is my return value, which will be that tomato potato. We no longer need this function, and if we execute it, it works perfectly. So now we have default values, but what if I would like my class to have more fields, but not all of them should be initialized by programmer? For instance, I could add my product, like some food like cheese, and it should hold a date time, but set by system, not by the programmer. Let's create a property that holds a date time. I will call it added time or added date time, and it will be of type date time. We have to import. That's great. Imported date time from date time. And let's create a field. Programmer should never be able to initialize that value himself. So in that case, I just specify init equals false. And the problem is solved. But I also need some default value, so let's use default factory param, and we will pass datetime.now. Let's now run our code. And yeah, we have current time, and what can I say? Happy New Year 2024. The only issue is that that value may be very useful for the system, may be very useful for the staff in my store, but not that handy for my application users, for some customers. Maybe I want to hide this value, or maybe it's just annoying me because it takes so much space in my Python console. If I want it to be excluded from the print, I need to add a new parameter, repr, and set it to false. Let's run the code again now. Issue is gone. The last thing about initializing data classes is freezing them. By default, we can access and modify instance properties. Actually, let's do it. Let's pick a product, maybe the first one from the list, so notebook, and let's set a new price. I want it be to something really expensive, like 20,030 cents. Let's execute the code. Works fine. We printed the correct value. But what if my data came from database and I want to make sure that the data in my application is always the same as in database? I want to be sure that no one was able to modify it because that data will go to another system and will be processed and processed, and I want to be sure that I have that consistency. I want to know that no developer was able to adjust the data in the class, in the object, to make it simpler for processing and forgot that it could have broken something else. So it means I want this data to not be mutable. I would like to freeze it, and that's the keyword we were looking for. Our data class decorator can take some arguments, and we can use frozen one. Frozen equals true, and if now I try to run my code, I will have an exception because we can't assign a new value to that field. So let's remove that line, and now everything works again. But what if we need some more nice features? Maybe like comparing our instances or ordering them. We can implement comparison mechanisms for our data class the way we compare regular classes. It would make sense to be able to compare data classes we have by price. For that, we would have to implement methods like equal, dunder method for equalization, and lt, dunder method, which stands for lower than. That is a very classic approach, but data classes support a special sort index field that is a value that tells us where to position our instance in order. Comparison methods are actually already generated for data classes, so if we were implementing them ourselves, we would kinda get rid of that nice functionality. Let's use built-in ordering instead. The first thing we have to do is to add order parameter and set it to true. And I will also get rid of that frozen argument just in case I want to modify something. Once order is enabled, we have to add a new sort index attribute and make sure not to make any spelling mistake. That value should be an integer, and I don't want any user, any programmer to be able to initialize it himself, so let's create a field init as false and also disable it from printing. Right now the value is not initialized, and what we can do is to have some initializer. But we already discussed it. Initializers are already generated for data classes. So I could probably try creating my own initializer, but in that case I would no longer have advantages of data class. I would have to initialize all those values myself. Luckily, there is a solution. There is a special method, a dunder method for data classes that is called post_init that will be initialized just after the initializer. So here we can set self sort index to an integer, because remember it is integer and I want it to be float based, so I always have to cast my price to integer, and our application works with dollars, so each dollar consists out of 100 cents, so let's multiply it by 100. And also here I have to access price using self keyword. Now that works, but if you want to make sure that that is actually set properly, you have to set repr back to true. So let's execute it. That works. We have some sort index, so let's disable printing that value again. And now we could use that sort index to sort our array. So before printing the array, we can just call products.sort, and now it is sorted by price. And also there is no issue with the fact that there are two products that actually have the same price, and that means they also have the same sort index. It still works. If you want to, you can even try comparing products. So let's add a print that will tell us a comparison result, and let's compare the first, the cheese, with the last, which is t-shirt, and I suppose t-shirt is a higher number. So products, and let it be the first one. Is it bigger than the last one? Let's execute the code. No, it's not bigger. That's great. And now it's the time for the last thing I would like to teach you, and that is using slots. It's worth noting that all Python objects and instances are usually based on dictionaries. Even though we see them as objects, they are usually dictionaries under the hood, and you can even access them using dict dunder method. Let's actually do it. Let's get the first of the products and dict. We can wrap it with a print and see what Python will tell us about it. We see all the elements, but also if we put a breakpoint here, in our debugger we are able to see it in a form of list. And who knows, sometimes we may also have some additional information. And also we see all the types of the objects we have here, and we have some date time. So we can try accessing that date time. At the date time, maybe that has the representation. That actually doesn't, so that means it is probably slot based. And that's actually good, because datetime doesn't have any other functionalities than storing a date, and that may be used very extensively in the application. If you have thousands of records of products, you will have 1,000 datetime objects. So it's very good they used slots, because that reduces memory that objects take and also speeds up accessing their attributes. In typical classes, you would have to define a special slots variable that would define names of all attributes that the class may use. So in our case, that would be some slots equals, and here we would have a list, and there would be sort index, there would be name, there would be price, and more. That has a mixed reputation and it's not obvious for beginners, but luckily data classes let us do it in a simpler way. Data classes are already generating an initializer for us, comparator methods, string dunder method, and also can generate slots for us. And all we have to do is to set slots to true in our decorator. What was changed is that now attribute access is faster and that takes less memory space. On the other hand, we no longer can call dict dunder, and also we cannot add a new attribute during runtime. That means that if I try to access my product 0 and add example equals probably to none, that is not going to work. On the other hand, if I wasn't using slots, there would be no issues whatsoever. In most cases, I would treat using slots as a default. It's a free performance gain, but the only thing you have to keep in mind, really, is that it causes trouble when using multiple inheritance. In a nutshell, that means that if you have two classes that use slots and you want to create a new class that inherits from both of them at the same time, it's not going to work. That is because you are inheriting some slots list and the new class has no idea which of inherited slots should be used. They would probably have to be mixed, but that doesn't really work. It's been a long video, but I hope that a helpful one. You may feel a little overwhelmed, but you will hopefully notice that the very basics like defining a data class and using default field values can make your code cleaner. Other features can bring you a lot of value in future, but the very basics are often all you need. If you want to get more into data classes, I really recommend the official Python documentation. And data classes are quite new and are being developed. In Python 3.10 there were some new features, and who knows, maybe future will give us even more.